Hey guys, Mr. T here. Just another video, this one on Venn diagrams and solving problems with them. So Venn diagrams are really useful to model real-world problems. That's what we're aiming towards by teaching you about Venn diagrams. So these problems generally only involve the number of the elements in each set rather than looking at the actual numbers of the elements themselves that you've done in previous questions. So let's have a look at this particular question. So the example is, a street has 30 houses, 16 of the houses have an alarm, 22 of the houses have a security door, 10 of the houses have both of the security features. So the first part of the question is we want to represent this situation with a Venn diagram. And then the second part is answering some questions about the situation using the Venn diagram. So how many houses have an alarm but no security door? How many houses have either an alarm or a security door? Or how many houses have either an alarm or a security door but not both? So these two sound very similar, but they're not exactly the same. They're very slightly different. So starting with A, represent the situation of Venn diagram. So in the Venn diagram, there's a rectangle representing the universal set. So the universal set here is the 30 houses in this street. So everything that we do within this rectangle has to add up to 30. So that's the first key to keep in mind. So some of the houses have an alarm, some have a security door, and some of them have both. So I found the easiest way to do this is to just ignore the both to start off with and work things out later. So I'm going to go the circle to represent the set of houses that have an alarm. So that's the circle for A. And I've been told that there's 16 houses with an alarm. And then the other thing that I've got is a set with security doors, and there's 22 of them. But remember, this is ignoring the 10 houses that both have security features. Alright? So the problem that we've got here is that everything within this rectangle doesn't add up to the 30 that we said before. You've got 16 and 22, so that's 22, 28, 38. That's too much. Okay? So what can we do to fix that? Well, that's to consider the overlap, the ones that have both. So 10 of them have both security features, so that's in the overlap. And if I've taken 10 have both, that 10 is taken away from either side because there's 22 houses with a security door, but now I've said 10 of them have both, alright? But these 10 also have security doors, so this 22 has to be 10 less to represent the fact that I'm considering the overlapped ones, so that is now going to be 12. Same with the alarms. There's 16 houses with the alarms, but I've got an overlap of 10. So really, the set that only has alarms but not also a security door is going to be 16 minus 10, 6. So let's consider what we've got now. 12 plus 10, 22, 23, 24, 25, 26, 27, 28, 28. So I've got 28 that have security features, but the street has 30 houses, so what does that say? Well, there must be 2 houses that have neither. So we can answer B now. How many houses have an alarm but no security door? So this is the set that represents houses with an alarm, but they don't have a security door. So we ignore the overlap. So there's going to be 6 houses with alarm, but no security door. So that's B1. B2. How many houses have either an alarm or a security door? So if you read into this, what you care about is they've got either of the security features. They've either got an alarm or security door, so that means they could have both as well. So we're talking about this set, and this set in the middle. So really, we've got 6 plus 10, 16, plus 12, so 16, 17, 18, 28. 28 houses with either an alarm or security door. And the last one, how many houses have either an alarm or security door but not both? So we're thinking about having either security features, so these two, but we want to ignore the houses that have both. So instead of 28, it's going to be this 6, and this 12 is going to be 18. So 18 houses with either an alarm or security door, but not both. Alright. So that is just an example of doing a problem and representing it with the Venn diagram. Hopefully that helps you out, and I'll see you in the next video.